So again, looking at number 2 on page 104. The way to think about these, so we've created this like crazy expression for VI. We went like around the barn 3 times to get that expression for VI, not quite, but when you look at this problem then, look at it and say, okay, well if I had VI, how would I solve this? And pick an equation based on that. So let's do this again. We've got our x, we've got our y, we've got VIx, VIy, VIx equals oh, I made that too small. Okay, so for number 2, we've got our expressions for VIx and VIy. We know that there's no acceleration on the x. We know that acceleration on the y is our negative 9.81 meters per second squared. We know our x displacement, 301.5 meters. And what we're looking for, well, we know our overall delta y, and that's really important. And one thing that's really important to keep straight, so delta y overall is 0. One of the things that's important to keep straight is at different parts of the motion, there will obviously, we know, there's an x point for every y point, etc., for every moment in time. When we're building expressions, we want to kind of mentally keep those things together. So like if we're writing an expression that gets at the initial velocity and we're using the overall y displacement, we want to use the overall x displacement. So we're relating that point in time. Okay, so aside from that, and we know delta t is generally our bridge. So if we had no concerns that we didn't have VI, how would you solve this? So Vx equals delta x delta t, delta t equals delta x, Vx, and then we're looking for the highest point in the flight, so we need something that gets us a, that connects displacement. Well, see, now that's gonna help us with our VI, but we don't want that right now. So what we're looking for is this maximum y, the y max. So there we need something that's going to relate initial velocity, final velocity, displacement, and acceleration on the y-axis. So we could use, what expression could you use that would tie those things together of your 4 goldens? So just to get that, disregarding the fact that we don't know VI, so thinking back, outside of that little problem we have, VF squared equals VI squared plus 2a delta y. So we're now talking about those on the y-axis. So can we solve that for delta y? Well, of course we can. Don't be silly.
Did we already do this?
Nope.
Oh, no.
No. Okay. Well, we know that we're looking at a point where the VFY is 0. So that goes away. Okay. We still have a problem, don't we? What's our problem? We don't have VI. Yeah, we don't know VI. But we created an expression for VI. And that's what we're going to plug back in. So what we have is the negative of VIY squared divided by 2a gives us delta y. And this is at the max point because we put that in as 0. Okay? So that dictates that we're talking about this point in time, this top of arc. Okay, let's go back to our work from yesterday. Our expression for VI that we created yesterday, and I won't go through the derivation again. Apparently people do not want me to do that. So, it was a little bit ugly. I'll be the first to admit. Yes. Do you need it right now, or are you bleeding all over the desk?
Not all over the desk, but all over my shirt.
Oh, well, yeah, let's get... Okay, so we've got 2 sine theta, cosine theta. So that's VI. So now we know we can do one other thing here. Okay, so we have to remember that VIY is going to be VI, and VIY squared is going to be VI squared times sine squared theta. Well, now we have this whole ugliness that goes right into there.
Oh, wait.
Our saving grace is the fact that that's a radical and that's squared, so that's kind of a nice little gift.
Right. VI sine theta squared.
You can.
Because I really don't like this.
Well, you can, but what's going to happen, because your VI is a radical expression, so do you see what's going to happen?
Yeah.
Wait, where did
The that thing's gonna disappear.
where did this
Yeah.
That
come
was
from?
gonna disappear.
Where did this expression come from?
The VI squared sine squared.
Because we had here VIY squared, so that's VI sine theta squared, or VI squared sine squared theta. So let's actually move some of this mess over to the next page. Okay, so do you see where this is going to go?
Yes.
Yeah.
This is not fun.
You know what? I think
The algebra gets a little bit uglier in the next chapter, but you'll come to love it, I promise. Yes.
We're already approaching
Josh, your sense of humor is so
We're
delightful.
already approaching British television levels.
Is it because they can hunt?
British but ugly.
No. I forgot to keep recording this. Sorry, Josh. And no, Jack's there.
Yep.
This
That's
is
it,
Josh.
Just Josh.
That's what he gets for skipping.
Okay. Yeah. Sorry, Josh.
Is that on the
Is legal only because we made delta y 0, which is only true at the full flight. So the 301. It's a good train of thought, but no. Okay. You know what I'm going to do? I'm going to pull out the plutonium. That's good. That's good. Now I want you to look at those things. Okay. So here's their derivation. Vy final equals Vi sine theta.
We lost the squared on the delta t at
This is straight from their manual, straight from their solutions manual, which I don't always agree with.
they use a different book.
Well, they do use, this is from a different book, but some of the problems were the same. Like, they're different numbers, they're different pages very often, but like if I look at the variable, sometimes I can find the same problem. Like there are some problems that aren't in our book that are in this one, and some problems in our book that aren't in this one, but I can find some parallels. Okay, so they've got delta t equals Vi sine theta, so that would be VIY over acceleration. And they end up with Vi equals the square root of A delta x cosine theta sine theta. So we had A delta x over 2 sine theta cosine theta.
ours was negative.
Well, that's because they do the whole G thing. That don't even, yeah, I hate that thing. So ours was negative and that was okay. Our negatives ended up going away. So their sine stuff is going to be a little bit different than ours.
We didn't have that goal.
That's not a golden equation. No, don't get too excited about this yet. Don't get too attached yet. I'm not excited about any of this, Moser. No, I wouldn't. Okay, we'll continue working on this booger of a problem and the rest of the boogers of a problems on Wednesday when we all come back. I'm recording. So, no, heavens no. Okay.